Okay. All right. Seeing how there's no questions, we'll start on the lesson today. So 2.2, we're going to talk about weighted means. So as always, we'll start out with an example. So it says one rule of thumb is that college students should spend 2 hours studying outside of class for every hour in class. So it says here's the study logs for 2 students in 1 week. So the first student, Ben, it looks like all of his classes were 3 credit hours each. But he spent 6 hours studying in the first one, 6 in the second, 4 in the third, and 5 in the fourth. So all we did was we just added up the total, so how many credit hours and how many total hours studied. And then we did the exact same thing with Kate. Okay? So it says find the overall average number of study hours per credit hour for each student. Are they meeting the college rule of thumb? So how we can find this average is just like we found the mean in the past, right? So we have our total here and we have how many hours they studied here. So we're just going to divide the two. And the way that it's worded up here is it's 2 hours studying outside of class for every hour in class. So in the numerator, we're going to have the studying outside of class. And then in the denominator, we're going to have in class, right? So for Ben, we'll have 21 hours divided by 12 hours, right? And then for Kate, we'll have 19 hours divided by 16 hours. And if we do that in our calculator, if we just divide those two numbers, we should get, so 21 divided by 12, we get 1.75. And for Kate, we get 1.19. I'm just going to round it there. So 1.19. So the question they ask, are they meeting the college rule of thumb? Well, the college rule of thumb is at least 2 hours for every hour in class, right? Which they're both below that. So they both do not meet the college rule of thumb. All right, so that's the first part. But now it says, find the hours studied per credit hour for each course, and then average those 4 rates. And then it says, does this match the result for Ben's average in part A? Why or why not? And then do the same thing for Kate. So what we're going to do, instead of summing them all up and then dividing by them at the end, we're going to just look at each row, right? So this one, for history, it looks like he studied for 6 hours total, and there were 3 credit hours. So we do 6 divided by 3, which is 2. Right? So his number of hours studied in history is 2 per hour. If we do the same thing in statistics, we get 6 divided by 3, which is 2 again. So we got 2 down there. Psychology, we have 4 divided by 3, which is 1.33, right? And then we can do the same thing for English. So we divide 5 by 3, and so we will get 1.66, right? And then finally, after we do that, it says to find the average at the bottom. So we're going to add all those up and divide by how many there are. So we're going to add 4 things up, divide by 4. And if you do that, you should get 1.75. 1.75. Okay. So everything with Ben's matches up to exactly how it is up here, right? Now we can do the same thing for Kate, right? So we'll do this. We get history is 6 divided by 3, which is 2. Math is 6 divided by 6, which is 1. We get 4 divided by 4 for chemistry, which is 1. And then we get English, which is 3 divided by 3, which is 1. Right? So to find our average, we add all those up. So that'll be 5 divided by 4. So 2 plus 1 plus 1 plus 1 divided by 4. And we get 1.25. So everything with Ben's looks good, right? It matches the average up here. But if we look at Kate's, it's 1.25, whereas we looked up here and it's 1.19. So we want to know, well, why is that different? If they're both averages, why do we have a different average down here than the one that we calculated in part A? So if we look at Ben's credit hours here, we see that he has 3 credit hours in every single class. So each credit or each class is weighted the same, right? So each one's a 3 credit hours. So it's similar to GPA, right? Like if you have a 5 credit class, it's going to be worth more to your GPA than a 3 credit class, right? Since these are all weighted the same, if we just take an average of each one of them and then add them together, it's the same thing as adding them all together and then taking the average, right? But with CATE, we have different credit hours, right? So this math credit hour is worth twice the amount of history, and it's worth twice the amount of English, right? So with that, that means that the amount of study hours towards math is going to count more, towards how many hours they studied rather than history or chemistry or English. Okay? So this is kind of what we call weighted averages. When something has more credit hours, it might be worth more than some of the other classes, right? So why are they not the same? It's because they have different credit hours for CATE. So that's the important concept here is we have these different credit hours and we call those weights. So these weights means that some classes are taken into more of an account when we're doing certain means or certain averages rather than history, okay, or another subject. All right. Any questions on this first page?
No.
Okay. All right. We can go on to the next page then. So what we just did, we're going to, or what we did was called a weighted mean. And all a weighted mean is it's just like finding an average, but we have certain weights or certain values are worth more than others. Okay. So the way that we look at this is we have our first value multiplied by our first weight, plus our second value multiplied by our second weight, and so on till our last one. So we're still doing a weight, but we are maybe averaging them differently. Okay. So in math speak, I guess, a weighted mean, how we can find that. So that's our little formula here. This sigma, it's just a capital sigma. It's a Greek letter. That just means you're summing things together. You're adding things together. So you're just adding the value times the weight of all of them divided by the sum of the weights. Okay? And I know that's a little bit of a weird notation, but we'll do some examples to show you what I mean. Okay. So it says find the weighted mean of 15, 25, 100, and 250 if 15 carries 4 times as much weight as each of the other values. Okay. So I'm going to write down my formula again. So I have the sum of the values times the weights divided by the weights. Okay. And that's equal to, so my first value, or my first x value is 15. And I'm going to multiply that by the weight. It says that 15 carries 4 times as much weight as the other one. So it's going to be 15 times 4. And then I'm going to add to that. My next value is 25. And I can just say that that's a weight of 1, right? Because it's 4 times less than 15 if we look at it the other way. And then I can add that to 100 times 1. Right, so we still have the same case there. And we can add 250 times 1 at the end. And then what we're going to do is divide that by the sum of the weights. So my weights here are just my second numbers that I'm multiplying. So I have 4, 1, 1, and 1. Right?
Why are we having 4?
So 15 carries 4 times as much weight as the other ones. So we say that each one of these just has a weight of 1, and 15 has 4 times that much. Right? So 1 times 4 is 4.
Okay.
Okay? Okay, so that's our top, that's our numerator. And our denominator is just the sum of the weights, which is 4 plus 1 plus 1 plus 1, which is 7. Okay? Okay, so then now we can just calculate that, right? So 15 times 4 is 60, then add 25, add 100, and add 250. So we get 435 on the top, 7 still on the bottom. And we should get about 62.14. So our weighted mean here is 62.14. So the way you could think about this, if you had maybe in the terms of a college class, if this is worth 4 times more, you could think of that class as worth 4 credits, where the other ones are only worth 1 credit each. If that kind of helps understand. Okay, so your weighted average is 62.14. Does anybody have any questions on that one? All right. So let's try another example. So this one says, suppose a student has earned points in 4 categories, and the teacher uses the percent weights listed in the table that follows. So find the student's percent and letter grade in the class. Assume the instructor uses the normal scale, right? So if it's 90 or above, it's an A, 90 to 80 is a B, and so on. Okay. So we're given how many points each student has, and we're given these weights down here, right? It just depends on what category it is and how much it's worth to this class. Okay. So what we can do is we can do the same formula where we have these weights, right? Because we have a weighted mean here, whereas like the midterm is worth 40% of your grade, whereas a homework is worth 10% of your grade, right? So your midterm is going to more affect your grade than your homework. Okay. So what we can do is we can have the same formula. So I'm going to write down the same formula as last time. So we just have the sum of the values times the weights over the sum of the weights. Okay. So when I'm looking at this, before I actually do any work, if I look at the sum of the weights, well, my weights here are just how much each one's worth in each category. And I know that my grade is just 100% of the grade I get, right? So if I add all these together, I just have 100%. So I'm just going to divide this by 100%, which is just 1, right? So really, we don't even have to worry about the weights here because we know that it's just going to be 1. We don't have to worry about the denominator. So all we need to do is just the top part, right? So what I'm going to do is I'm going to do my first value, so my homework. So the value I got on my homework is a 94.4%. So 94.4%. And I'm going to multiply that by its weight, which is 10% in this case. It's worth 10% of the grade. And then I can add to that my quiz grades. So I have an 87.5%, and it's worth 10% of my grade. And then I can do the same thing for midterms and the same thing for finals. So I got a 66% of my midterm. It's worth 40% of my grade. And then finally, I got a 63% on the final. And that is worth 40% of my grade as well. So I just have all my values for the 4 categories multiplied by how much they're worth, which is the table. And then I know that I'm just going to divide that by 100%, but I don't really need to worry about that because that's just 1. Right? So we can do that. So I'm going to do that on my calculator really quick. So I'm getting, this person got 69.79%. And the way that I calculated that is I changed these percentages, so the weights, into decimals. So I multiply the percent by the decimal just to get how much it's worth out of that 10% of the grade. and then I did that with the rest. So that one's 0.1, 0.1, 0.4, and 0.4. Okay. So I just changed these ones into decimals and then multiplied that by the percentages to make sure it stays in percent. So if we go back to the question, it says find the student's percent, which we did. And then it also says find the letter grade in the class. So if I look at this, it looks like he's below a 70, but he's above a 60. So this student should receive a D. But I know some teachers round to the nearest percent, which would be a 70, so they might get a C minus, just depending on the instructor. So. All right. Does anyone have any questions on this page? All right. So let's look at the next one. So the next one says, the data represents the ages in years of cats at a shelter. So it says find the average number of cats. So it says instead of entering the values into your
Matt, I'm sorry. I was just working through my own math. I was a little bit behind.
Mm-hmm.
For the weighted average, you got 69.79.
Yes.
On that one. Okay, great.
Mm-hmm.
Thank you.
Yep, no problem. Okay. So on the next one, we're just finding the average age of the cats. So we just have a bunch of cats at a shelter. So instead of just averaging these, so just taking a regular mean where we're just adding all these together and dividing by how many there are, we're going to have all the ages and we're going to have all the frequency. So just how many cats there are. Okay? So if I look at this table, the first thing I'm going to do is just fill in the ages, right? So the first one I have a bunch of that are age of 1. I have some that are 2. There's some that are 3, 4, 5, 6, 8, 11, and 15. Okay, so I'm just filling in all the ages that I see in the numbers that are listed. And the frequency, it's just how many of each cat we have, right? So it looks like I have 1, 2, 3, 4, 5, 6, 7 that are age 1, 3 that are age 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that are age 3. 4 that are age 4. 5 that are age, or how many? 1, 2, 3, 4, 5, 6, 7. I get 11. I think 11 that are age 5. 2 that are age 6. 1 that is age 8. 1 that's age 11, and 1 that's age 15. So I'm just counting how many there are. So my age times my frequency is just the first column multiplied by the second column. So I have 1 times 7, which is 7. 2 times 3, which is 6. 3 times 10, which is 30. 4 times 4, which is 16. 5 times 11, which is 55. 6 times 2, which is 12. 8 times 1, 11 times 1, 15 times 1. So 8, 11, and 15. Okay. So this column that we have here, this age times the frequency, that is just the same thing as my x values multiplied by my weights, right? So that's just my x values multiplied by my weights. So this, if we add all these together, that's just the top of our weighted mean. So if we take the sum of our x values times our weights, that's just the sum of this column, right? And then we're going to divide that by our weights. So we just need to know which ones are weights. So is our age weights, or is the amount of cats in each age category their weights? So are our weights ages or frequency? So So I'll open that up to you guys. What do you think? Are the ages the weights, or the frequency, the number of cats in each age group, the weights?
Would be the frequency of the weights.
So the frequency, we're looking at just the number of cats in each category, right? So we don't necessarily say that a cat that's age 5 is worth more than one that's age 1, right? They're both just cats.
Right.
So the frequency is just our X values, right? It's just the number that we have in each category. So that means our weights would have to be the age of the cats, right? So a cat that's age 15 is 15 times older than the one that's age 1, right? So when we're taking our average, our weights are going to be our ages. I'm just going to put a W down there. So our weights are just the ages of the cats. Okay? So now what we can do is we can take the sum of the column here. That'll be the top. And then we'll take the sum of the weights, which is the bottom. So I don't know if anybody's done that. I have to do that really quick.
160.
Okay, so we have thank you. So we have 160 when we add this column together. And then do you have the sum of the ages yet?
No.
Okay, that's fine. I'm getting 55. So we get 160 divided by 55. And we get about 2.91. So we have this, but what does that mean? What does that number mean?
That's the average age of the cat, a little less than 3 years old.
Yeah. So the average age of the cats in the shelter is just under 3 years old. So I just want to label that. So average age of cats. I'll just leave it at that, I guess. Just to make sure that we answer the question and it's clear to anybody that might be reading this, right? So just average age of cats. Okay. Awesome. Does anybody have any questions on this page? Okay.
Where did you get the 55?
So 55 is just the sum of our weights. So that's just adding all the ages together. So it's just the
But
sum of
I don't get, oh, the ages, your weight,
Yes.
or you're adding together. Okay,
Mhm.
thank you.
Yep. Yeah. Any other questions? Okay. All right, so we've talked about the weighted mean. So we're going to talk about a different measure of the center. So a different measure of the center, we have the median. And it's basically just the middle value of the data. So instead of adding everything together, we're just going to label, or we're just going to order something from highest to lowest. And we're just going to cross out the lowest value and the highest value till we get to a center value. Okay? So the example that they give is that we have these sets of values in our data. So this is just the first one. I'm going to rewrite it up here so it's easier to see. So we have 72, 74, 76, 78, and 80. And they're claiming that the median is 76. So it's just that number right there in the middle. So the way you find the median is you just cross off the lowest and the highest value. So we cross off 72 and we cross off 80. So those essentially cancel each other out. And we do the same thing for the second lowest and the second highest. So we just cross out those. And the only number that we have left in this case is 76. So basically the way we find our median is we just label, or we just order things from lowest number to highest number. And we just cross off till we reach a middle number. So we cross off the very outer ones and the second outer ones, the third outer, and so on down. Okay, so if we try the example here, it says, find the mean and median for the data set of ages of college students in a study group. If the student who is 55 years old joins the group, how will the data value affect each center of measure? So let's find the mean of this first. So how do I find the mean of this set of numbers? So how do I find the mean?
This wouldn't be a weighted mean though, would it? It would just be your mean.
Yeah, it's just
Correct.
a regular mean, right?
So you're gonna add up all the numbers and then divide it by however many numbers are there.
Yeah. Yeah, so this one we just add up all those 8 numbers and then divide by how many there are, which is 8, right? So I'm going to find the mean. That's equal to, I know it's going to be divided by 8, so we just sum all those up. We add all those up. We get 18 plus 22 plus 25 and so on.
164.
I'm getting 163. But
Oh,
either way, it's going to be pretty close, so it shouldn't matter in the long run. So we get that
finger point.
and divide by 8. So I'm getting about 20.4 for our mean there. So that's the average age of someone in this group. Okay. But now we're also going to find the median. So we're not just going to find the mean. So the median is equal to, and what I'm going to do is I'm going to order these from lowest to highest first, and then I'm going to cross them out. So it looks like my lowest value is 17. Then I have one that's 18. I have 2 that are 19. I have 20, 22, 24, and 25. Okay. So I'm just ordering the numbers from lowest to highest. And now what I'm going to do is I'm going to cross out the lowest and the highest value, and I'm going to keep doing that until I reach a center value. Cross out 17 and 25, cross out 18 and 24, cross out 19 and 22. And now we have a problem, right? So we have two center values. So the way that we deal with this, if we have 2 center values, is all we do is we just add them together and then divide by 2. So we just add these together, 19 plus 20, and divide them by 2. So our median here is 19.5. So our median of the group is 19.5. Okay, so we found the mean and the median. And now what we need to do is we have a 55-year-old that joins the group. So now instead of having 8 people in this group, we have 9, right? So our mean, we can easily find our mean from this, right? So we know that it's 63 on the top. So we can just add 55 to that. And then instead of dividing by 8, we divide by 9. So our new mean is 163 plus 55. So we get 218 over 9. So we get about 24.22 there. Okay, so that's our mean. And then our median, we can rewrite this, but then we can just add 55 to the end, right? So our median, I'm just going to rewrite from the earlier part. So we have 17, 18, 19 twice, 20, 22, 24, 25, and then we're going to end with 55 now. So still just labeling it lowest to highest. Okay. And then we can do it just like we did up here. So we're just going to cross out the lowest and the highest value and keep doing that. So cross out the lowest and the highest, the second lowest, the second highest, the third lowest, the third highest, the fourth lowest, and the fourth highest. And we converge on a value of 20. So since there's only one, we just have 20. Okay? So the question is, when we added that 55-year-old to the group, how did the data, that data value of, so 55-year-old, affect the measure of each center? Well, if we look at the mean, it looks like it rose almost 4 points, right? Because it's going from 20.4 to 24.22. So it rose almost 4 points, or 4 birthdays, I guess. So it rose by 4 points. Whereas if we look at the median, it's almost unaffected, right? It just raises by half a point. So if we look at this context of this question, it looks like the mean was affected way more than the median here. Okay, anybody have any questions on this page?
So why, why, um, why are we wanting two different sets of numbers for this? I mean, I know I know the difference between median and mean,
Mhm.
but what are we trying? I'm
So
sorry. I'm like really tired. I just got off a 16-hour shift, so I'm just kind of
you're
muddling
fine.
through.
So why do we look at two different measures of mean or measures of the center of a set of data? Is that like what you're
Yeah,
asking? Yeah.
right.
So sometimes the mean is not necessarily as helpful because the mean sometimes it's affected by these big numbers like this 55. You see how it's like really skewed off now, where we have this 24, that 24.22, it's actually greater than over half the people, right? Like only 25 and 55 are above 24.22, right? So maybe it's not necessarily the best indicator of a center in some cases when you have these things called outliers. So you have like this 55 where this number is a lot bigger than everything else in the data set. So when you have these outliers, maybe your mean isn't your best way to look at your center of your data, where maybe as the median is a lot better because now you have half the numbers below it and half the numbers above it. Does that make sense?
Yeah, it does.
So sometimes the mean is worse at showing the average than the median is. So it just depends on the situation. Okay.
It's like throwing a millionaire in like a working class thing when you're trying to throw a median and a mean.
Mm-hmm. Okay. All right. Any other questions on this page? Okay. Okay, so this one says, this is a data of annual salaries for nurses at a clinic, and it says to answer the following questions. So it says, what is the mean salary and what is the median salary? So I'm going to give you the mean salary. So I'll look up the answer to that really quick. But I want you to find the median salary. So find the median salary of this chart. And you'll see that they're all ordered already for you as far as lowest to highest. Okay, so our mean here, so if we added all those up, all 20 values and divided by 20, you should get 57,580. So this is one of the reasons that we have Excel for Microsoft Office, is because sometimes you're going to have so many numbers or really large numbers that it's going to be hard to add them all together and make sure you don't make mistakes. So if you're dealing with thousands of these, like maybe you have a huge company and you're dealing with thousands of people's salaries, right? And you're trying to find the average. It's going to be a lot better to do it in Excel because you're less likely to make a mistake, right? So the mean salary here is 57,580. And did anybody get the median salary?
I got 52,500.
Yes, that is correct. So you just crossed off the lowest and then the highest and kept going on in, right?
Right. And then because I was left with 54,000 and with 54,000 and 51,000,
Mm-hmm.
I added those two together and then divided it by 2.
Yep. Yeah. So instead of crossing them off one at a time, you can cross off whole rows if you want. So we could cross off the 5 lowest and the 5 highest at the same time, right? So if I crossed off the 5 lowest, and then I can cross off the 5 highest, right? And then maybe I don't know exactly where the center is. So maybe I'll only do 3 this time. So I'll cross off 3, the 3 highest, and then the 3 lowest that are left. Then I see I have four numbers left, right? So then I can just cross off the highest and lowest that are left, and I end up with 2 numbers. So you don't necessarily have to cross off the highest and the lowest, the second highest, the second lowest, and so on. You can cross them out a bunch at a time, as long as you kind of know where the center is. Okay, so the question is, which is higher, the mean or the median? Well, the mean's definitely higher, right, by about 5,000. So the mean is higher. And the question is, why is the mean higher? So the mean is higher because we have these outliers. So these 2 numbers at the top that are 6 digits, so those are way higher than the lowest mean, right? Like the 31,000, and there's a bunch of 31,000s actually. So we have these outliers. So that's a new term that I'm going to bring up. So we have these outliers, and basically what outliers are, they're just numbers that are way above or way below the mean. So in this case, we have the 100,000 and the 125,000. So those are our outliers. And if you go into statistics, you'll talk about outliers a lot more. There'll be a way to define outliers as well, rather than kind of like the hand wavy definition that I gave you. So, but that'll suffice for this class, is the outliers are just numbers that are way outside the value of our mean. Okay, so let's try the next one. So the next one says calculate the GPA for this student. So I think this is another one that I'll let you do, and I'll give you a hint that this is going to be a weighted mean because you have different values for your credit hours for each of the courses. So the first thing that I would recommend doing on this one is changing the grades on the right to a GPA scale, right? So I know that a C is a 2.0, a D is a 1.0, a B is a 3.0, and a C is a 2.0. Okay. So I will let you do this one, and then we'll come back in just a second. Okay, so which one is our weights? Are our weights our credit hours or the grades that we got in the classes? Well,
The credit hours is the weight.
yes, yeah. So the credit hours is just how much it's going to affect your GPA, right? So if we look at math, the math 096, it's twice the weight of the English class. So it's going to be worth twice as much when it's figuring your GPA, right? So our weights on the bottom, so the sum of our weights is 3 plus 6 plus 5 plus 3. So that's what, 11, 17. So we get 17 for the sum of our weights. And what did we get on the top? So what is our values multiplied by our weights and then summing all those
33.
together? Yeah, and how did you find that?
I so with English, I took the 3 credit hours times 2 plus, and then just went down the line.
Yep, 6 times 1, 5 times 3, and 3 times 2. Yep. So we're just multiplying our weights by our X values or our grades, and then we're summing all those together. So what did you get again on the top? I'm sorry.
33.
33. Okay. So if we do 33 divided by 17, we should get